Welcome to Application Provisioning with DSC and Octopus Deploy, a world where developers manage their own configurations. So imagine that you're a developer and you just spent a bunch of time on a web app and you're excited to push it out to your production systems. But the current process is you need to provision those servers, and to do that you need to submit a ticket. And you know after you do that you're going to be waiting for probably 3 weeks before it gets provisioned. Now the flip side of that, imagine that you're a sysadmin and you just got paged at 4 in the morning and you had to fix a production outage and go into work at 7, and you get this request. You get a request to provision some IIS boxes, maybe 20 or 30 of them, and you think, this is a rather ridiculous request. There's got to be a better way. And so if you're like me, you'd think, the solution to this is really just some PowerShell. It's really just a PowerShell script, problem solved. I'll just run it every time I get this request. But there's really kind of two problems with that. It's, who still has to run that code? You do. And so this whole concept, this application provisioning with DSC and Octopus Deploy, is really a story how we offloaded that work to our development team. They're the people that understand what it needs to take or what it needs to be provisioned like. They know all the parameter values. And so this is kind of a discovery of a solution that allowed them to do that. And the main message from this is automation is the answer. We all know that. But who you write automation for and how they use it is actually more important than the automation itself. So to start off, I'm going to go through what I call my Dsc Cave of Trials. I didn't only want to just automate it with PowerShell. I wanted to use DSC. DSC is really cool, really awesome, and it has an X-WebAdmin module that takes care of all the IIS provisioning. And so why not use that? Well, bringing DSC into an organization was way more difficult than I had originally envisioned. And so my first implementation of that, first failure, was a monolithic control. From a sysadmin perspective, I had a tendency to centralize everything, centralize logging, centralize domain controllers, and some kind of isolation. So I had one configuration file that, depending on the role of the servers, would generate a different MOF document. The problem with that, though, and the problem with DSC and the MOF delivering, was anytime any of the apps made a change, it recompiled every single configuration and reapplied it, even though there was only one change to maybe 5 servers instead of 200 servers. And so that didn't scale. It didn't fit the needs of the developers. The other problem was it was written in DSC and in native PowerShell. And our user base is developers, and mostly Windows developers, and so they didn't understand that syntax and that DSL. So we moved on to a slightly more complex one, and we tried to use partial configurations. This fell flat on its face almost immediately just because of the complexities, where you got this team writing this configuration and this one over here, and you're merging them together, but the thing is that they have to run at the same time. They all compile into one and then they run together. So it still had a lot of the same issues that the first one did. And so from the ashes of these two failures, I kind of went on an uncharted path. I looked at a lot of the tools that were out there in the industry that were successful. I knew that I wasn't going to get buy-in to buy one of these big config management tools, so I tried to emulate it as much as possible and create custom tooling around what would meet our specific needs. And so out of this uncharted path became a lot of requirements. Grab a sip here. So after those two failures, we got a lot of requirements. And the requirements are driven by things that they didn't like. The very first thing was they needed a friendly format. DSC and PowerShell wasn't native to them. They didn't know how to use it. And so we asked them, what would you prefer? And they came back with JSON. I was like, I don't think it would be too hard. There's other people that have done YAML extractions or abstractions of DSC. I was like, I could probably do a JSON one. Why not? The next requirement was simplified execution. Again, that MOF document that ran the entire server config was a problem. They wanted to run just the provisioning for their app at deployment time, not the entire box. And so with that, I looked to the community, and I looked to other platforms that were using it, and they were using InvokeDSC resource that one by one invoked resources and gave us that flexibility to use the LCM, the local configuration manager, more as of an API instead of run everything in this configuration document. They wanted it to deploy at provision time. So this was actually a really good segue into being self-contained. So what we did was we took that friendly configuration document and we put it in their source code. And now when new applications and APIs get spun up, They also get a configuration document for their Iis app. And that way, they could deploy at deployment time, and everything would be self-contained, and they're not dependent on some kind of bus or big configuration having to go through beforehand. It's just when the code runs, it gets provisioned, and then it deploys the web app. So the design overview is this. It starts in source. So their source code with all of their C# code or whatever code they want to write also has a config.json. And this JSON is strictly just a file that provisions their Iis stuff and maybe creates some directories for their logging, and also sets the ACLs for that. The next step is that source thing kicks off with CI and it gets built. The product of that is a build artifact. So now they have all of their code and their configurations for their provisioning inside a NuGet file or whatever they choose to compile to. That is then sent over to our deployment tool, which you can probably guess by the heading of this talk is Octopus Deploy. Octopus Deploy then does two things really. It could do several things, but it provisions the Iis app and then it deploys the web app. This also gets us away from people getting ahead of the deployment schedule for Iis and then ending up in inetpub and causing issues later on down the road with cleanup and so forth. So that is all the slides for now. But before we jump into the demo, we're first going to look at the web app JSON configuration. So this is a DSL abstraction of DSC to make it more friendly for the developers. And we'll take a look inside the NuGet artifact. This is pretty stripped down. There isn't actually any deployment code in there. It'll just be the artifact. But this is to note, I'm not going to be demoing any CI work in here, but just know that the source control is then compiled, test, or run, and then a build artifact is generated. And then we're going to be taking the demo from that point on. After that, we'll dive into Octopus Deploy. We'll take a look at the web app project, which is how our applications are set up to deploy. And then the InvokeDSC App Config, which is a step template that wraps PowerShell that invokes a custom module that all this came from. So everything under the hood, this abstraction of JSON to DSC is a custom resource or as a custom module that's out in the community called InvokeDSC. Then we'll create and deploy a release and talk about variable substitution that you get for free with Octopus. So let's dive into the demo. So here we have the JSON DSL. It basically has two object constructs. It has the modules object. And so what we wanted to do is we didn't want to have a dependent. We're not using a poll server, obviously, in this case. So how do we get modules around? And we wanted to give the flexibility to developers to add resources if they were so inclined to expand upon in DSC. So the modules array simply takes the name of the module, and it takes the version. You can put null in here, and it will grab the latest. But this is a string that would then go and fetch that module. So there's some helper functions inside the InvokeDSC module that will go and reach out to the repository you specify and dynamically pull them down. There are specific versions that we do lock the version of, like package management. Mostly ones that just have breaking changes that don't have backward compatibility is what we exclude from here. And you can have as many as you want. The next object is Dse Resources To Execute. So again, this is going to look very familiar to anything that's abstracted out. If there's a Puppet or if there's a Chef or even some of the other custom stuff that's out in the community, there's an Ansible module that abstracts it out into YAML. It's a very similar concept where you have the name of the resource. This is an abstract name. So in this case, it's web app folder. And that's just the name of the resource that you're going to be calling in here, the name you're giving it. The DSC resource name is the actual DSC resource that you are calling. So in this case, it's file. And then after that, inside that same object are the properties that you would get from DSC. So if you wanted to, can you see the terminal okay? You could do get DSC resource file syntax. And those same properties you could just match over into the JSON. Now JSON has different types that you can use, so it is type sensitive. If it requires an int, you would want to put it in your JSON. Not everything is text like YAML is, which made it a little bit easier in the comparisons. The type that this is going to be, so destination is one of them. You see this weird syntax here. for people that have used Octopus Deploy, you recognize this as an Octopus variable. So this is one of the two ways that you can replace variables, is you can just put them in the code. Now, there's a better way that you can do that if you want to have offline compatibility outside of Octopus. But sometimes the escape sequence gets weird, and that's your only option. So that's one way. Per different environments, you can replace what's in the JSON document and get a different result per your environment. So if the password's different here versus over here, you can change that. The type is going to be a directory, and it's ensuring that it's present. Anyone that's familiar with DSC, it looks very familiar. It's just the properties. So what this config consists of is creating two directories. It's using the X web app pool to create an app pool and define some properties there. Again, you can see that some are typed. Some are string, some are bool, some are int. Then it will create a web app. This is the fun part with the sim type. So in DSC, some resources use sim types, and they can either be an array sim type or they can just be a single instance. And so that is why you see the array here for authentication info. And this CNTFS permission entry is also one that uses a sim type, and that's setting the ACL in the directory so that the app pool for that app can log to a specified directory. And so what you can do is you can use this as a kind of a template. So when new applications come up, you can just copy and paste whatever their names are or their folder paths, and you can keep it very consistent. That was another problem that we had, is someone would submit a ticket and they would put in a different log directory, or they would name the app with hyphens or underscores. And this keeps it really consistent when you spin up new APIs with microservices. So any questions on the DSL itself? Here? Yeah, it is. So it's how I'm handling. If I do some more detection later on in the convert function to see if it needs to be a sim type array or a sim type single instance, and so that's why that's there, because it could be an array, and then so I would compile the PS object to do that. So to give more context for this is the JSON that a converter function that I've written takes and converts to a PowerShell custom object to then hand off to InvokeDSC resource. And so probably not the perfect way to do it, but it's worked for us so far. A lot of people have done, I think, you got JSON, there's YAML, there's been other, PSD1, yep, Brandon's in that. So we'll see in the demo if it's wrong, but I think it'll work. But thanks for pointing out. Any other questions on the DSL? Okay. So at this point, you've seen what that, so this lives with the developer's code base, and what happens is the CI process would build that artifact, and then would push it to Octopus. So we come over here into Octopus Deploy. And we can look, so in Octopus they have a packages library, and if you come in here, I have several of them uploaded, but one of them is the web app. So this would be the application that was pushed from our CI pipeline into Octopus. And so we can download this and open it in NuGet Explorer. Now, if this was a real web app, there would be more code in here, but you can see that this is just the configuration document living. I don't know if that zooms in, but it lives alongside the code. And this has been, there's a few reasons we chose to do that. It gives more ownership to the development teams, but also gives them a lot easier access to changing their own configurations. So what we've seen now after we've implemented this is teams have been doing pull requests to each other's repos or to their own repo to fix their provisioning issues. And we've seen almost all provisioning issues completely go away for applications inside our ticketing system. So that metric is, I think we get them, and usually when the tickets come in, we say, hey, you can fix this yourself. And they're like, oh, great, I'll take care of it. So that's been phenomenal to see the customers giving them a tool that allows them to help themselves. And so that's the real value of what this has done so far. Okay, so the next thing that we'll talk about is the actual project. So it's fine and dandy, there's the DSL, developers can write that, but how are you leveraging Octopus to deliver these? And so we'll take a look at the web app application. So in Octopus, Octopus has the concept of a process. And so these processes are run sequentially, and you can actually have variables that, conditions that they will run. So the very first thing that it does is it deploys the web app. So this is that NuGet artifact that was uploaded to Octopus. It lays it down, so when Octopus has tentacles, those are the clients, and then it shoves it down and runs everything in a local context. It's not like you would have CI and it would remotely invoke everything, it's a local context. So it would deploy that down. An important thing to note here is how Octopus targets. So this project is going to get deployed to an environment, say development, but how does it know what to go to? And the concept behind that is what are called tags in Octopus. And we use them, so like this is only going to get deployed to the web server, web-server. So if we were to look into infrastructure, tentacles healthy, good, the lab won't fail. You can see that we have web1 and it's tagged with a target role of web-server. So that's how we can detect what goes on anything. So if you wanted to go everywhere, you could create a role called all or something like that, and it would go across everything. But usually you want different types of configs to go different places. So if this was web app 1, it would go to the servers that need web app 1. And that way it gives you the ability to deploy to multiple different targets through roles. The other thing that this does is it has two features that are enabled on this deploy that you can either do JSON configuration variables, which allows you to transform just the JSON object stream. So that was a reason why there's objects at the top and bottom. So we can go object by object and then replace. So if we were to go back and look at that configuration, we'll take a closer look later. But I could go Dse Resources To Execute, web app folder, destination, and change this. Change this here without having this weird Octopus variable in there. So I could run it locally, or I could run it in Octopus, and the context would change. Like I said, the reason for doing the Octopus variables is it tries to interpret your JSON for you, and so if you have a lot of escape characters, it gets messy. So, and then the other one is to substitute the variables, and that's exactly what you saw there. So it's going to find an Octopus variable, and it's just going to substitute it. So when it gets deployed to the node, it has the variable that it needs. Any questions there? Feel free, any questions welcome throughout the entire talk. So if we go back, the next thing is InvokeDSC App Config. So this is actually a step template, and in Octopus, a step template is a way to wrap commands in PowerShell or whatever language that you want to use. And so you can see right here I have two parameters. I have path and repository, and then I have a little link here to the actual step template. If you look at the path, it's got another weird Octopus variable. That's actually referring to the previous step and saying, where did you put your payload? And then it's adding the configuration file here at the end so it knows what to invoke. So that way you don't have to push it to a custom location. Octopus has a default location you can use. The next is I'm pointing it to a repository. So this could be an internal Artifactory server, or it could be the PowerShell gallery or some other feed that you could pull NuGets from. And this is very important because if the node doesn't have the application or the DSC resource modules that it needs a way to get them. And so that's where that modules object came into play. It goes through there sequentially and then downloads them from whatever feed that you have. So mine's going to use the PS gallery. Yeah.
So does that repository parameter take multiple repositories? So if you have maybe a private repository for custom build, the array had the defined two, I guess it was not that had two modules that you needed. They were both on PS gallery, which were great with a single repository.
So the question was, can that field, that repository field, have two and check against two sources? Current way that it's implemented, no, it can't. It only goes against the one. It just wraps around find module and install module with some sorting syntax to fix the weirdness. So it doesn't do that. Something to mention is you can add those feeds to Octopus by going to library and external feeds. So you can see I have the external feed of PowerShell. I can also pull internally, so if you felt the need, you could upload them all to Octopus if you wanted. If you don't have a NuGet server or any kind of artifact source that you could pull from and you don't want to pull from the gallery, you could just use Octopus itself. And you would just upload them to packages, like I have here. So if I didn't have internet access, I actually had them all in here, and I could use an offline way to distribute it through Octopus. So great question, thank you. Back to the step template. So like I said, Octopus has these concepts of step templates. The idea there is that you can reuse the same code multiple times and share it across and update all of them. It's not easily source controlled at this point, so what we opt to do is kind of keep it to a minimum. Can you see that okay? Is it kind of small? See it okay? All right. So it's rather simple. It tries to import the DSC module. If it can't, it just stops, it throws, because there's no point in trying to invoke the configuration if that module dependency isn't there. So the next thing that it does, creates a nice little splat hash table there, and then passes that to InvokeDSC configuration. Again, here's where it's using that path variable in the repository. InvokeDSC configuration is a wrapper function inside that module that both does the install module, that's a private, or I think it's a public function, and then also invokes the DSC. So it basically wraps both of those, so you can point to a configuration, pull down the module dependencies, and install and invoke the configuration. It also takes input objects. So that was a pull request that I got as soon as I put it up on GitHub, is why doesn't this accept input objects? So you can put JSON here strings in here as well. So if you didn't actually want a file on disk, you could just pass it into a code block and run it. We wanted to have some kind of historical record, and since it's coming from source as a file, it made sense. So that is all of that. We'll go back, and then here's my cheating web app. I thought about learning some C# and getting a web app going, but I didn't have enough time. So it's just going to write output deploying web app, ... But ideally, you'd have like a MS deploy or something like that there that would deploy your web app. So now what we'll do is we will go ahead and create a release for this. And notice here, one thing that I should have mentioned in the artifact. See how that NuGet is named 001 and there's a version here 001? That's tied to the release. So you actually have, that was a huge benefit here, is what version of the configuration was ran against that node. And since it's in source now, and their build pipeline versions all their NuGet packages, that code is now versioned. So you have an idea of what broke in what version. And then that's all captured in the Octopus release. So we'll go ahead and create the release for 001. And we'll deploy it to the development environment. Deploy. So it might take maybe a minute to acquire the packages. So questions will fill up time. But right now it's acquiring the packages from Octopus. It's going to deploy them, transform variables, invoke configuration, and deploy the web app. And we'll walk through this. The other benefit here is we actually have logs now inside the same release that the code went out of how the app was provisioned. So it went ahead, and you can see right here it's transforming variables in this file because it found some Octopus variables in there that it was going to transform. I have some JSON ones that replace the same value, and then it's also using it to replace that Octopus value. If we come down here to the app config, the function, the helper, the InvokeDSC is written the same way that DSC would execute this, where it tests whether the condition's true or false. That was another huge benefit of this. Before, we just had brute force PowerShell scripts that go in like, hey, we're going to delete this directory, and then we're going to create it again, no matter what, even if nothing's changed. So this is a softer touch with that. And then again, an advantage of the Dse resource. Oh, no problem. I invoked the phone over there through Octopus. I could do anything with the internet connection, right? But you can see here that it's executing on Web 1, and it goes sequentially through those resources. So instead of using the depends on, because InvokeDSC resource is independent, there's no way to tie those together, so it's a sequential execution. So it goes through, and deploys or tests the web app one or the web app folder, and then does the set. I'm still working on cleaning up. Hopefully I can steal some more of Brandon Nolan's code to clean up InvokeDSC resource to not put out verbose output when I don't want it to. But it goes through and does test set, test set, test set, because all of those it was a new box and they didn't have the changes. So if that wasn't the case and they didn't change in their provisioning on the next run, we would just see tests and no sets. Any questions there?
Really for the start test, the failed test, and that's it.
Yep. Native DSC would do the same thing. I think native tests again after it sets. That's not in there. But how I get around that is with some pester tests. But you can see that it outputs. I try to mimic the verbose logging of DSC as much as possible. Octopus is a little bit weird with this. You take the verbose of PowerShell and you verbose it again with Octopus, and it gives you a ton of stuff. So this is actually output messages that pull in what resource it was using, and then also the name of the resource the name that you gave the resource. So it's access log, but it's actually using the CNTFS resource. Okay. And then there's my fancy write output. So the next thing that we'll take a look at, I'm using containers here, so I actually have the volume mounted for the applications. And if we go to applications, so this is the default location that Octopus would deploy down these artifacts. And what I'm going to do is look at the artifact after it was deployed so you can see the variable substitution. So it goes underneath applications, and then you can see all the projects that were deployed to this. We're going to go into the web app, and we'll go into the most recent one. And we'll open up the web app Iis Config. So here again, there was the old one without the transform, and here is the new one with the transform. So you can see it replaced the JSON in that way. So how did it do that? It did that through Octopus Variables. And so if we come here, there are different scopes. There are different ways to have Octopus variables. You can have projects, you can have local. All of these are local variables to the project, so if you delete the project, the variables go away. In Octopus, you have the concept of scoped variables. So you can see the bottom two are scoped only to development, and the rest are undefined, meaning they will apply to every environment that you deploy to. But the bottom two will only transform or apply when it's pushed to the development environment. And that's how you can get a config management tool system out of this, is by using these variables to change as they progress through environments. Because oftentimes you don't want the same password in all your environments. So again, here is how you would navigate with the JSON transform. You would have to specify your top level object, which is Dse Resources To Execute. The next is app pool, and we can see that path here. We go Dse Resources To Execute, web or app pool. And then it's doing idle timeout action. So idle timeout action is what we're transforming when this gets deployed, and it's being set to terminate. The same thing for the app pool name. It's just going to be web app. The log application, this is the name of the web app in Iis. And then down below is the destination path. Now notice how these have double slashes and this one doesn't. And that's because the Octopus is going to, it will literally replace the text with whatever it is there. Because I'm using a JSON transform here, it handles some of that escaping for me. So for this one, if I were to put straight JSON, I would need 2 slashes for Iis app pool whack web app. But because it knows that I'm going to transform a JSON file, it does that for me. And that's where you get, if you have a lot of escape characters, it gets weird. Like if you were going to try to put a regex expression in here, which I did do. It didn't work very well. How am I doing on time? Really good on time. So the next thing that we'll take a look at is how did InvokeDSC resource get there, and how do I handle the distribution of that? So this was another fun learning experience that I got. out of this project. So we're now dependent on this InvokeDSC resource heavily. It's provisioning all of our IIS apps. And one time I introduced a breaking change, and it broke 3 of our testing environments, our QA environments. And I said, you know what, there's probably a better way to push this around instead of just blasting out to everything that needs it. And when one of my teammates came up to me and he's like, well, why don't you just use Octopus Deploy to deploy your module across the environment and bootstrap your dependencies through that? And I was like, you know, that's a fantastic idea. So that's exactly what I did here. So this actually has a whole pipeline to it as well. So it has sources internal. It goes to CI, it builds, it runs all my pester tests against this module, and then it pushes a new version of Octopus, and it creates a release from Team CD in here, and it goes to our dev environments for vetting. So if we look at the process here, there are some hard dependencies that this module has. It needs a specific version to handle the bootstrapping of package management. There were a lot of breaking changes in the early versions of package management that made the commandlets, like the parameters, change. And so we needed to control at least a few modules. We use pester to validate the changes that this has made, since we're not using get resource or have a moth that can pull out all that information. So we're using pester to validate that. So we wanted to make sure the latest version of that is out there so we don't have to worry about syntax errors in our pester tests. It does, of course, deploy InvokeDSC. And we had some fun with the max envelope size, returning back to Octopus, so we set that. And then for my lab, I got lazy and I wanted to make sure that the PowerShell gallery was trusted, so when I tried to reach out for modules, it didn't crash and give me a prompt error. So how do I version lock these? Like, we want a specific version of package management, a specific version of pester, and so forth. How do we do that? And the answer is, in Octopus, you can set versions in channels. So the channel here is a default channel. You can have multiple channels, and that's how they deploy. So a channel, for instance, might be, you have to go to dev before you can go to stage. You have to go to stage before you can go to production. Those channels and life cycles will define that. But an advantage of this is that you get to define version rules. So whenever this gets created, it's never going to allow you to pull down an artifact that is higher than version 1170 for package management. The same is true for pester. I'm using version 4.1.1. And then for InvokeDSC, it's actually tied to whatever the latest release came from the build. So if version 2093 came out, this would have to get updated. Any questions so far? So let's take a look at this deployment here. So it goes through and copies those. Let's look at the process, actually. So here's a nice little trick that you can do to place it in the directory that needs to go. So DSC pulls everything from the PowerShell, the program files. And so I'm just giving it the Octopus NuGet version package here. So that way I don't have to come into these steps every time and change the version. It's just going to take whatever that NuGet version is and create a directory and put it in there. So I think I'm way under in time, so we get bonus material. So any questions with the IIS application provisioning itself and how developers can contribute to that and the infrastructure overlaying that? None? Okay. Very good. So bonus time. So with this, we ran into some issues where, this is working great. It's working for all our existing web servers. But what happens when the infrastructure team introduces a new node and they haven't installed web server? Failure. That's what happens. I'll fill in the gaps for you. So I looked out to, again, the community, and I kind of, so we got this nice tool. It abstracts as JSON. We like that. I personally started to enjoy writing DSC more in JSON than I did in native DSC, mainly because I didn't have to compile them off and go through that rigmarole. It was just really handy for me, and plus I could test really quickly with the hash tables, or with the here strings rather, and just put it in there and test locally on my systems. So it was fantastic, and we took that a little bit further, and we said, how can we, because we're not going to get approval, or maybe it's not that we wouldn't get approval, we kind of didn't feel like fighting to get approval across the entire organization for a CM tool. How can we take what we've written and use it to do config management? And what we came up with was Ansible-ish. So, because it was heavily, heavily influenced by a lot of the stuff that Ansible has done. And before we get into the process, because it's really simple, let's take a look at what the library looks like. Open. Let's download, there we go. That is not fun to read. This is all bonus and on the fly. So this is on GitHub, what's part of this project that all of this actually is. Here we go. This will work great. So what we did was we decided to mimic Ansible as much as possible. And we have these JSON documents, and they're all defined by roles. And so if we come in here, we can see that we have two different roles. So the problem we wanted to solve is this box doesn't have the web server feature installed. We don't want to remote into it and install it or use Invoke PowerShell or put it as part of the application deployment, because that would be silly. Why does the application deployment need to check that web server is installed every single time? So we came up with this. And so we devised the common.web.json. And what this does is it uses that same DSL, and it goes out and installs the web server and then just some random other web stuff that I wanted to have on here. So this is obviously way more encompassing. It kind of bootstraps, some directories and some file permissions. Anything that we really want, we can do in here. And we can deploy it with Octopus. So we also have another common one, and we got to put Chocolatey in there, because that's how we're going to get our software. We're not going to have random PowerShell installers or have to log into it. A lot of the use cases for this were for build agents, and they just required a bunch of software to compile code. And so we just use Chocolatey for that. So how does this all work? And that most of it is inside this inventory file. So inside this inventory file, you have a host object, and then inside there you define all your hosts. If you've used Ansible, it looks really, really similar. So I have Web1, which is the tentacle that I have in my lab, and then I have a few different environments. Octopus Environment is going to be development. So this can be read and hooked into like PowerCLI, which is what we have a VMware stuff, so it could hook into that, or it could hook up into Hyper-V if you want to create a link module, because really now you have a document that defines the way that your infrastructure could look, a basic one. So you could at least create those VMs or modify those VMs for that. So it uses those two variables to define how it's going to be put into Octopus. It's going to be in the development environment, and it's going to have the role of web server. And it's going to have these roles, because we wanted to make it as agnostic to Octopus as possible. We didn't know if we were going to continue to use this, and we didn't know if we were going to continue to use Octopus for it. So it goes through, and it will invoke these roles in these orders. And the only thing that Octopus is doing is orchestrating this, and it's defining deployment targets. So now that you have an idea of what the code base looks like, we can take a look at the app deploy. So here's Ansible-ish. It deploys down the package. It can use the same variable transforms as before, so that's not a non-issue. And then it goes through the Invoke Playbook. The Invoke Playbook is a little bit more complicated than the last one, because as we ran through this, we iterated and be like, you know what? Sometimes we got to reboot these things. Sometimes we want to exclude roles. Sometimes we want to say only this one. And so that's how you can see here, is it grabs the Octopus name. You then specify the path to the file that you're going to call. You give it a repository so it can obtain objects. And then you can do include, exclude, and then you give it the inventory name. So this one step will run against all the servers in that call. And then invoke the role, so it's independent of Octopus. If we look at this, PowerShell code, it's a little bit more complicated. So this is actually, the Invoke playbook is .sourced in, so we could source control that step template. And then it basically, the rest of it is just the construct of the parameters that are being fed to it. So we're doing the if else include, all that logic, and we're splitting the string into an array as it comes from Octopus in a variable, and then we're invoking the playbook command. So that playbook is actually source controlled with the inventory file and all that good stuff. So we can take a look at this in action. I'll just redeploy version 001. Development. Oh, I did not mean to cancel. Okay. Couple minutes. Perfect. So it gets to the same process, but the community lightning demo yesterday showed how you could use a DSC through that, and they were running a bunch more steps than I am here. I just chose to extract more of it out into PowerShell and into a code repo than to have Octopus handle a lot of those different steps. But this is a way that you can use Octopus, a tool that maybe you have. We chose to use it because it was a tool that we had and my entire team was familiar with it. And it made a lot of sense for us to at least experiment and prove out the theory of config management and environment and get a quick win, so to speak. But you can see here that it reports back to you, hey, I found this configuration that you were expecting to run. It runs it, it tested it, it passed, so it didn't set it, and then it went and found the web common, or the common web, and ran the test against the features. So whenever we ran into that issue, we would just run this project versus remoting into the box, and now everything is self-contained into our CI and CD tools. So let me minimize this. Bring this back up. Shift F5 would have been better. So the moral of the story, it's okay to build new tools. You can use familiar systems, and that's going to be a great advantage because your entire team doesn't need to skill up on a new tool. This was just using PowerShell and Octopus. We were the deployment engineers, so we knew Octopus intimately. So it was just a good fit. It made a lot of sense. Help them help themselves. So we're reducing that. We actually cleaned up a lot of bandwidth that we could do. Automating the provisioning gave us the bandwidth to actually do the config management tool stuff. So you got to help your customers help themselves. And who you build automation for and how they use it is actually way more important than the automation itself. If you write a really cool function and you got to run it all the time, you still got to run it all the time. Put that extra effort in and make it more usable from your customer standpoint. So this has been application provisioning with DSC and Octopus Deploy. Thank you for attending.